Subtracting rational expressions. Actually, these instructions are exactly like adding rational expressions. Find the least common multiple of the denominators. This is the least common denominator. Convert each of the expressions to an equivalent fraction with this LCD. Subtract the numerators. Write the result over the least common denominator. Simplify if possible. So let's work these example problems. Compute and simplify. So we're supposed to subtract. You can only subtract fractions if they have the common denominator. These have that common denominator. So we're going to simply subtract the numerators. 5. Be very careful. It's minus x minus 1. That minus is like a distributive property that you're subtracting both the x and the 1. So that gives us 5 minus 1 is 4 minus x over 2x. And that's it. You cannot cancel anything, so you're through. Let's do another problem. What happens when your denominators are opposites? This is very similar to our problem on the previous page. Let me talk about fractions in general. Suppose you have negative 1/2. Is that the same thing as negative 1 over 2? Yeah. Is that the same thing as 1 over a negative 2? Yes. With a fraction, you can put the negative out front, you can put it with the numerator, you can put it with the denominator. So, in this particular problem, I'm going to rewrite 7 over a negative 9 as negative 7 over 9. That's the same thing. So I made the denominator the opposite of what it was. I had to make the numerator the opposite of what it was. So now I have 5/9 minus a negative 7 minus a negative gives me plus a positive. 12/9. 12 and 9 are divisible by 3. 3 goes into 12 4 times. 3 goes into 9 3 times. So my final answer is 4/3. So when we had our denominators were opposites, we made the second fraction, we made it a positive. We had to make the numerator the opposite of what it was. And notice that had the effect of changing this subtraction to addition. That's kind of a fast way to think of it if you can remember that. Let's look at this example. Oh, we get to use that very idea here. Compare that to the previous problem. Notice that these denominators are opposites of each other. And notice that we have subtraction here. Let's leave the first fraction alone. And how can we address the fact that it is subtraction and the denominator is the opposite of our first denominator? We can change this to a plus and change this to the opposite. Does that make sense? The negative that we would factor out of this denominator, the negative 1 that we would factor out, would cancel with that minus and make it a plus. So since the denominators are the same now, we can combine the numerators. We have 3a minus 2a gives us a, minus 7 plus 5 gives us minus 2, over a squared minus 4. Are we through? Is there anything else we can do? Can we factor that denominator? And then what cancels? And that leaves us with 1 over a plus 2. And that's all we can do. Let's look at this problem. The denominators are not the same, so we have to identify the common denominator. It needs a factor of w, and it needs a factor of w minus 8. Let's fix this denominator. It has the w, but it doesn't have w minus 8. So we're going to multiply numerator and denominator by w minus 8. Let's fix this fraction. It has w minus 8, but it needs a w. So we're going to multiply numerator and denominator by w. Multiply the numerator, w minus 8 times 5 gives us 5w minus 40, minus, we're subtracting here, 3w over w times w minus 8. Combine our like terms, 2w minus 40 over w times w minus 8. Are we through? Is that all we can do? I think so. That's the answer. Let's look at this combination. We have subtraction and addition. So we have 3 different denominators we're looking at. So you know I'm lazy. I'm just going to factor this denominator right beneath it. It's a y plus, it's not plus 2. What is it? Plus 1 plus 5. Boy, I was tempted by that 2 plus 3, but that's not right. All right, so let's identify the common denominator. The least common denominator needs a factor of y plus 5. It needs a factor of y plus 1. And that's all. So our middle fraction is in good shape. It has the common denominator. But our first and our last fraction need a little help. What are we going to multiply this fraction by? What are we going to multiply this fraction by? So now all 3 fractions will have the common denominator. So we can just write that common denominator. And we can add and subtract the numerators. So our first numerator is y plus 1 times 8y. We need to multiply that out using distributive property. 8y squared plus 8y minus 7y plus 4y plus 20. Combine our like terms in the numerator. 8y squared. 8y minus 7y is 1y plus 4y is 5y plus 20. Y plus 1, y plus 5. So I'm looking at that numerator and thinking, can I factor that? Because if I could factor that and there was a common factor with the denominator, I could cancel it out. But you can't. You try, but you can't. And so that's it for this page. I'm going to look at this 5.1 revisited. Rational expressions involve division. We cannot make a replacement of the variable in the denominator that allows division by 0. So we're very careful about what values we allow for our variables. We do not want division by 0 or an undefined fraction. Find all numbers for which x minus 7 over x plus 3 is not defined. What is going to cause a problem there? We don't want to have division by 0. We do not want x plus 3 to equal 0, which means we do not want x to equal negative 3. So there's only one number for which x minus 7 over x plus 3 is not defined, and that is x minus 3. Find the domain, all allowable x values. Once again, we have a fraction. We don't want the denominator of the fraction equal to 0. We can factor this. It's a difference of perfect squares. There's another way to work this, but this is the way I'm working it. So we don't want x minus 7. That can't be 0. X plus 7 can't be 0. So x cannot equal to 7. X cannot equal to negative 7. So 7 and negative 7 are not in the domain. We can have any other real number but those. That's all of section 5.2 and a little look back at 5.1, and move on to 5.3 the next video if you need to.